With PySquare, we build the fastest decentralized network for instant payments, okay, for humans and AI agents. All the communication between agents will happen at the speed of the internet, which means milliseconds as opposed to seconds.
This material is for informational purposes only and is not intended to provide accounting, legal, or tax advice, or investment recommendations, or an official statement of Presto or its affiliates.
Hello, everyone, and welcome back to the Presto Research Podcast. I'm your host, Min, joined by my boss, Peter, as well. And as usual, we have a very special guest joining us, Grigore, the founder of PySquare. Welcome to the podcast. How are you doing today?
Thank you for having me, Min and Peter. Great. Looking forward to your questions. I know you have good questions. So
as usual, why don't we start with our usual question? I know you're currently a professor at UIUC, but how did you first get into crypto and what ultimately inspired you to build PySquare?
Yeah, so I got in crypto in 2016 when I received a message from Charles Hoskinson, and then very shortly after from Vitalik Buterin, both of them founders of Ethereum. And they said, hey, you can use your formal verification techniques that we employ in runtime verification. Runtime verification is my first company, which I founded back in 2010. And we do formal verification there. And they said, you can use formal verification for smart contracts. And we have some critical smart contracts and protocols that we need formally verified. And Philippe Dayan recommended you. Philippe Dayan was my student. You probably heard of Flashbots, right? So he founded Flashbots as well in the meanwhile. So Philippe Dayan introduced me to Vitalik and Charles Hoskinson, and here we are now. Fast forward, I'm a big believer in crypto and Web3 now.
Okay, but then from there, I think you were involved in several projects.
Oh yes, many of them. So yeah, we formally verified the first version of Uniswap, the Ethereum deposit contract, Aave, Compound. Almost every major protocol has been formally verified by runtime verification. So as a matter of fact, because of that, we saw lots of problems in protocols, in smart contracts, bugs of all sorts, design bugs, programming bugs. And then I started PySquare because I believe I know how to fix these problems and to do things properly from scratch. And that's why I started PySquare.
Actually, yeah, that's a very good segue to what was going to be my question, which is, what problems are you exactly trying to solve with a PySquare? Explain in a very kind of layman's term.
So I would say in one sentence, right? With PySquare, we build the fastest decentralized network for instant payments, okay, for humans and AI agents. And additionally, as a bonus, we also allow all programming languages and virtual machines for smart contract, okay? Because I thought that two of the major problems of blockchains and of other projects that we've seen before in runtime verification were, one, scalability. Blockchains are dead slow, okay? Let's put it bluntly. And second, limited programming languages. Okay? As you know, UIUC is very strong in programming languages. LLVM was invented in our department, right? The K framework also in our department. Lots of compilers and language support developed. And our students graduated and then they joined Web3 projects and they were very disappointed. They said, these programming languages are crap. Sorry about that. And we learn all these amazing languages and techniques, and then we join Web3 projects and they have these, poorly designed languages by non-professionals essentially. And that was very frustrating. I wanted to have all programming languages in Web3. You see, when you buy a computer. You don't buy a Java computer or a Python computer. That would be stupid, right? You buy a computer and then you run any programming languages on that computer. That's how Web3 should be as well. We should be able to program in any programming languages. So that's one thing. That's how we started. That's what PySquare wanted to do from the beginning, all programming languages. And second, we also solved the scalability problem. That was not planned initially when we started the company, but it was a must. And then, we solved that problem as well.
Just clarifying, so PySquare itself could be standalone chain, but also could be integrated into the existing chain as well, or?
Yes. But let me correct you. we are not a chain. Actually, as a matter of fact, we are pretty different from a chain. We believe that we know that the total order on transactions, which is what Bitcoin proposed, Satoshi Nakamoto proposed, the idea of a chain, to solve the double spending problem. And in the meanwhile, 6 years ago, actually, it has been proved scientifically in academic papers that you don't need a total order on transactions to avoid the double spending problem. There are other ways to do it. And we leveraged those other ways. And we apply not only for payments, but for arbitrary computations in any programming languages. Okay, so in other words, blockchains implement a very old belief that you need a total order and strong consistency. It's been proved that you don't need a total order, and strong eventual consistency is just as good. And that's what we do. But to answer your question, yes, we can integrate, and we do integrate with any chains, essentially. We can integrate with any chains. We have a product called OmniSet, which is a set of smart contracts on different chains that allow us to see everything actually that happens on other chains and to have a unified view of liquidity, right? So you can bring your USDC, let's say, from Ethereum, Arbitrum, Solana, Mega ETH, and have a unified view of all your USDC in one place, and then be able to do transfers at the speed of the internet, basically, through our decentralized network. So we are not at all against chains. We love chains, and we interconnect with the chains in order to unify liquidity. As a matter of fact, we don't even have the term TVL. Incorrect. It's an incorrect metric. We use the term TVU, which is total value unlocked. You see, so once we connect a new chain, we think that we unlocked the liquidity on that chain, because now applications on Fastset can use liquidity from that chain. Not to mention the network effect, because once you connect a chain, you also have, through OmniSet, access to all the other chains that are connected. So it's like a universal bridge, but it's much, much, much more than a bridge.
Right. Okay. Then what's a good way of thinking about the potential addressable market that you're going after? Is it the same market as major L1s like Ethereum and Solana and Mega ETH? Or is it maybe even bigger than that? Because it sounds like you're also kind of overlapping with the bridges that connects these different chains. So what's the good way of thinking about it?
It is the same, at least the same as any other chain. Okay. So one way to think about it, imagine metaphorically a car that runs on gasoline. Okay. And then you decide to switch to electric cars, to an electric car, right? It's the same. You can do exactly the same things that we can do with a gasoline car. You can go from point A to point B, but it's a better technology, faster, potentially more reliable, fewer moving parts, right? So there are some advantages, in the electric car, but you can solve the same problems. Now going back to our network, which is called Fastset. So you can solve the exact same problems that you solve with blockchains, but we eliminated the scalability limitation. There is not even a theoretical cap on the TPS. It's infinite scalability. Okay, so same like with the internet, right? You have a larger bandwidth, you can do more, right? You have a faster internet, you can do more. Faster computer, you can do more, right? So same here. The validator is getting faster, the internet getting better. You can have infinite scalability on the TPS. We already reached 250,000 TPS with a 3-month engineering effort only. So in 3 months, we implemented a protocol, a blockchain-like protocol, a decentralized network, which can sustain 250,000 TPS. And we plan to reach 1 million TPS by mainnet. Okay. So think about it this way, Peter. So it's like any blockchain, but infinite scalability. And at the same time, it is connected also with all the blockchains. So it is like imagine all the blockchains connected through wormhole, okay? But it's not based on guardians like in wormhole. You have a whole decentralized network, that is wormhole, right? But it's at the same time, you can deploy smart contracts directly on the Fastset network. You don't have to deploy smart contracts on chains, but you can bring the liquidity from other chains to Fastset.
I know that having this faster, TPS and everything, you guys are focusing on payments, but of course, you can see lots of chains also focusing on, hey, we have the best trading venue, or we have like the best maybe, I guess, Web3 gaming experience about for being fast. So what's their focus? Like, is it about payments currently, or you guys are also thinking about creating like a trading venue, branching out into different parts, or?
So the most obvious use is payments, and specifically payments for AI agents, right? With the advancement of X402. Now there is also a cousin of X402 called H402, which is even more open than X402. Agents now can literally make payments, directly on Web3, and blockchains cannot sustain that demand that agents have, because agents, you can even imagine now IoT devices like your fridge, can ask, the utility company, what's the price of electricity, today or right now, so that maybe, it will start the freezer or not, or it can wait, until midnight to start the freezer, to be optimal. Right. So now you can imagine that what we do on blockchains, transactions, payments, and so on, can be done at the speed of the internet for fractions of a cent, in cost. This unlocks a lot of possibilities, right? But, as go-to-market strategy, our plan is to focus on payments and specifically for AI agents. We are discussing with 3 AI agentic companies, Virtuals, Sentient, and Kite AI. And we hope to convince them to use Facet for agentic payments. But it's not only for agents, also for humans. After all, Bitcoin was invented, right, with this goal in mind, right? We need a peer-to-peer, decentralized, unstoppable, right, payment network. And to some extent, it succeeded. But we all know the scalability limit, that now we call it a store of value because it's so slow. Try to give it a positive twist, right? So it's a store of value. But the truth is that it kind of failed as a payment system, right? We cannot use Bitcoin as a payment system. It's expensive and slow, right? So at a minimum, we can think of Facet as a Bitcoin network, which is super fast. It's basically as fast as it can be. It's optimal in terms of performance. But at the same time, you can also have smart contracts in any programming languages. But we don't want to start with that because we need a payment system. There is no payment system yet. And now we see all these efforts, with Tempo, Plasma, these new chains, specially designed for payments, which in my view, they are a mistake. That's not the way to go. What they do, they basically, there is no innovation there, technologically speaking. It's just a blockchain technology as we have it, and with a bit of twists here and there, to make it integrated with payments. But it's still the blockchain technology cannot scale. Actually, they dream of having 100,000 TPS. Maybe they will have 100,000 TPS. But I think 1,000 TPS is too low for the future that is already here. Look at Visa, MasterCard, and other cards, probably together have like 100,000 TPS, only the credit cards. Okay, so if we want to realistically bring all these assets, right, to Web3, then you need millions of TPS very quickly. And blockchains cannot sustain that.
Got it. Yeah, I would actually want to go back to the AI agent application because I think, given many investors are so much focused on AI related stories and maybe because it's a new field, people want to learn a little bit more about that. So I think your solution can be quite attractive for anyone who's building AI agent, functional AI agent. But then you mentioned that you're talking with several teams to make this happen. But from these teams' perspective, what are the other alternative solutions that they can use besides your solution? Just to get a sense of like what kind of competition you're facing in that particular segment.
They can use blockchains. Actually, Virtuals uses Base. There is a protocol called the Agent Commerce Protocol, ACP, and that is implemented as a smart contract in Solidity and is run on Base. And the entire, so any agent action, you know how long it takes. It's not the inference. So besides the inference, right? Because with the agents, you can have inference and that can be arbitrarily long. But let's not consider the inference. Let's consider only the blockchain interaction, right? All the ACP smart contract protocol. takes almost 40 seconds. So more than half a minute. Okay, so you have to wait on base, right? 40 seconds for the agent to settle whatever he did, right? The payment and whatever he did. That's ridiculous. Okay. And that's for one agent. And it's a lot worse than that because all agents use the same smart contract, the ACP smart contract. So now agents have to wait for each other. Well, they have to wait for each other anyway on the blockchain because of the nature of the blockchain. The blockchain is a total order. So my agent and your agent will have to stay in line. One of them will go before the other one or the other way around. Okay. But additionally, they also interact through the same smart contract, which is just a terrible, I mean, it's the only thing you can do on a blockchain, but and we are discussing with them to migrate to faucet. That will happen instantly. Basically, all the communication between agents will happen at the speed of the internet, which means, milliseconds, not, tens of milliseconds as opposed to seconds.
Got it. Yeah. So, and the response from these teams have been, has been
Very,
good or
very,
like
very
what's
positive. So initially they don't believe us because, we appear to make, and, people in Web3 make all kinds of crazy claims. They are not, they make lots of claims and then you look at their technology, just a copycat, they just copied another blockchain or something, and now they make lots of claims, just a narrative, but without any substance. In our case, we wrote everything from scratch. Right. So our technology is not a blockchain technology. We couldn't use anybody's code. We just wrote everything from scratch. Okay. And basically because of all the hype in Web3, they don't believe us initially. Then we show them demos. We take them to fastset.xyz. By the way, if you want to go and play with the network, you'll see how fast it is. You experience the thrill of instant finality, right? You make a transfer, instantaneous, right? It will be faster than you can see. If we share the screen, it's faster than you can see it, on the video, that it happened. It's instant, basically. Right. And then when we show them that, they say, wow, actually this works. So let's do it. So they are open. You see, the AI agents will not care. They're about all this tribalism, I don't care whether I use Base or Mega ETH or Monad or whatever. I will use whatever is faster and cheaper. And that's what we give them.
I guess shifting gears a bit, I want to talk about first, whether you guys are planning to issue a token. And second, if you guys are planning, nowadays you can see all these altcoins without utility kind of failing. So how are you guys kind of focusing and designing your tokenomics side?
Right. So we'll have a token. It will be called SET, S-E-T, because we think of our new category, right? Because we are not a blockchain. So what are we? We are a set, right? All the elements are completely independent. Same like in a set in mathematics, right? Set theory, right? Everything is and also set from settlement, right? And fast set things quickly, right? So the token will be called SET, and there is an interesting model for how to compensate the validators, much better than in blockchains, right? Because we don't have any blocks. There is no proposer of a block, right, to take the fee. So what happens actually is that the validators. So the protocol works as follows: you broadcast your claim to the validators. Imagine 1 million validators. The validators validate the claim and send it back. They sign and send it back. And you have to make a quorum, you or the proxy. There will be some nodes that do only that, right? So they will have to aggregate the signatures. And once you have a quorum, 2/3 plus 1, you have exactly the same security guarantees as in blockchains, proof of stake based blockchains. So a quorum of 2/3 plus 1, then that becomes, the aggregated signature becomes the proof that the claim is globally valid on the network. Okay. So now you'll have a fee, a minuscule fee on the claim, and that fee will be split among the validators who participated in the quorum, you see? And now as a validator, you are incentivized to be in as many claims as possible. So you want to have a good internet, fast internet, and you'll want to have lots of cores on your machine to be able to validate as many claims as possible. Okay. So, and then You can also stake. Of course, if you don't run a validator, you can stake your set in validators. And of course, the validators will receive staking the fees and then also staking rewards. And they can be slashed if they misbehave, of course. So this is usual in some sense. Staking from a user perspective is the same philosophy. I stake, I get some interest. And the fees are distributed, okay, fairly among the validators. But there is another interesting aspect. I mentioned all these programming languages, right? So we allow, if you look on our architecture, right, the validators validate, but then we also have verifiers. And verifiers verify proofs of claims. I said payments. This is our first application, but we support any kind of claims. And what is a claim? A claim is something that comes with a verifiable proof. And there are verifiers that verify proofs. Okay, so you can have claims, for example, which are computations in any programming languages, and the verifiers will verify the proofs of those computations. Or you can have an AI agent that was running a TEE, and now you have a proof of execution, a proof of inference in that TEE, and the verifiers will verify that. You can verifiers which are KYC verifiers, right? Maybe your identity, right? You go to the government and the governmental institution will verify that you are indeed Min, and they will sign. And now you have a claim that is settled on the network that you are Min, that you can use to prove your identity whenever you are asked. Okay. And by the way, we also have privacy, but let's not get into that. Privacy is a separate layer on top. So the verifiers can also lie or misbehave, right? So they also need to be staked in case they, so we have a restaking architecture built in, same like EigenLayer, okay? So you can stake your tokens in the validators and then restake them in verifiers, okay? And this way you get yield not only from the network, from validation, but also from different verifiers for different services. So I think there will be quite a bit of buying pressure on the token. Yeah, of course, we cannot predict, especially the future, how they say it. But
how hard is it to become a validator at Pi Squared? Is it similar requirements with the other, other blockchains, or?
Much simpler. I mean, think of Monad or Mega ETH, for example. They need beefy machines. The most demanding operation will be signature verification. Okay, and our signatures are ED 25519. So these are some of the simplest to verify, the fastest to verify signatures. You can verify 50,000 signatures per core per second. Okay, because signature verification is the hardest thing, because once you verify the signature, then the update of the state, right? So the claim has been already verified, right? Before it gets to the network. When it gets to the network, you have a signature that says the claim is true. Just settle it like a payment. Update 2 balances. That's super fast, right? So what is expensive is checking the signature, verifying the signature. And you can verify 50,000 signatures per core per second on average cores these days. So if you have 24 cores, you can sustain as a validator a million TPS. And that's our goal, to have a million TPS at mainnet, at launch. And in terms of memory, you need 256 gigabytes of memory to hold the entire key value store in memory. Okay. There will be also service providers on the network. I told you verifiers, but the general principle is to have service providers, and some of them are storage DA layers, essentially DA, like EigenDA, for example. I have a partnership with EigenDA to store all the complicated claims. But the validators only needs 24 cores and 256 gigabytes. And you can buy this for less than $1,000, the actual hardware these days. So anybody can join. And the beauty of it is that the more validators you add, actually the faster the network is. Unlike blockchains, where it's exactly the opposite. Now you have more communication, more messaging between validators. Our validators don't even talk to each other, which is another thing that is hard to believe, but it's very well worked out.
Well, that's actually an interesting point, that the more validators you have, the faster it becomes, because then there's actually a network effect, which I think with a lot of a network, they issue tokens, but then it doesn't really have a design where token itself benefits from the benefits of network expanding.
I think the network expanding actually will bring more claims. I think the network will expand on a by need basis, right? So then if the network is being used and we reach a lot of TPS, then more validators will want to participate and they share the fees. right? So I think that will be good for the token, right? The more validators you have, the more TPS, and the more TPS, the more demand for the token.
And you think the process of burning the token is necessary for the tokens to capture the value, or not really? What's your view on that?
I'm not sure about that, but we think of burning a percentage of the fee, right? So for each, so we plan to have fees which would be really low. Think like the actual cost for 1 million validator. Let me tell you the actual cost for settling one transaction. If you have 1 million validators, the actual cost will be 1/100th of a cent. That will be the actual cost. Okay, so we are thinking of having a price of a fee of 1/10th of a cent, so 0.1 cents per transaction, which we believe is reasonable, and even for AI agents. So that's already like a 10x, value, and to burn 25% of it. But that's what we propose in our tokenomics at this point. But that will probably be, like with everything else, decided by governance.
Yep. I guess since we are kind of in terms of timing, we're about there. I just want to ask you our last questions. We talked about a lot of AI agents and the payment system. So how do you think the AI agent and also the payment landscape kind of will evolve in the next 5 years? And what kind of role would PySquare play in that landscape?
I believe that AI agents, they just started. I've been at Dev Connect in Buenos Aires last week, and I was amazed. Everybody's talking about AI agents. There are like probably at least half the events were about AI agents. Could be hype, a lot of hype as well. But the truth is that they are helpful. And there was a lot of push for everybody to own their own agent, right? You don't want to use ChatGPT, only, right? So you want to have your own ChatGPT with your own state, that your agent who knows you, who understands you, who knows your needs. And if that really happens, then we'll have billions of agents, and each of us will have a few agents, working on our behalf, one buying, vacation tickets, others, bringing you, articles of interest every day, news, and so on and so forth. And with that future, right? So all these agents will have to pay for services, for microservices, micropayments for microservices. And how? Right? Of course, they can use centralized services, but if you have a decentralized alternative, wouldn't that be better and more desirable? And if I think that would happen, and blockchains, they prove that Web3 and crypto are here to stay, right? But blockchains are just one way to implement Web3 and crypto. And they cannot sustain that AI agentic future that I think is already here, more or less. Even what we have now, they cannot really sustain. 40 seconds with virtuals, that's ridiculous, right? Right. So with that in mind, I think, of course, I don't know if Fastset in PySquared will be the big winners in the end, but I think the genie is out of the box. I think at this point we demonstrated that we can have Web3 and crypto at the speed of the internet. Once people, digest that and assimilate that, then they will not go back, right? If you buy an electric car and you really like it, right, and you don't go back to the gasoline car, right? Once you get a smartphone, you don't go back to the land phone. Science evolves, and now there is a solution: a decentralized peer-to-peer payment system, unstoppable payment system. Then that's another big problem with centralized systems, right? If we use AI agents use a centralized payment system, Google or whatever, look at the Cloudflare incident recently, right? AWS was down so many times, right? AI agents cannot afford it. So why should they use a potentially stoppable service when they can use an unstoppable service and equally cheap? So I think I'm optimistic about this future. And I think PySquare will play a major role. I hope we'll play our cards right and not make mistakes. We have to be very careful. We think long term. Everything we do is long term. Runtime verification, I founded runtime verification in 2010. right? And the company is still here making revenue, and that's how we think. We think long term.
Yep. So I guess before we wrap up, for anyone kind of interested in learning more about Pi Squared, where can they find more information?
Yes. So they can go to pi2.network and follow the links there. We just launched a DevNet, and definitely they should play with our protocol, fastset.xyz. Right. So if you don't want to read company stuff and just want to immediately play with the network, fastset.xyz. Yes. And they can also type my name. My name is not very common. So if they type Grigore Rosu, they'll find me. And from there, I like to be contacted. I like to answer technical questions, and not only technical. Yeah. So join our Discord, join follow us on Twitter as well.
Got it. Yeah, I'll also try the Fastset XYZ after this call. Yep. I think that's it for today. Thank you, Grigore, for sharing your insight, and see you guys all next week.
Thank you so much for the great questions.